So I mentioned a couple lectures back, if you want to take the derivative of the product of two functions, it's not as easy as just taking the two individual derivatives, multiplying them together. Doesn't work out. All right, the way we have to do it, and you've seen this already if you watched the previous lecture where I derived it. If you didn't, that's fine. We're going to talk about it here. If you want to take the derivative of the product of two functions, what you have to do is take the derivative of the first one times the second, and then do it the other way around. Take the derivative of the second times the first one. Add them together. Then you get the derivative of the original function. So let's look at an example. Right, this x squared, and I've already used f, right? So let me call x squared g of x, and this x cubed plus 1 will be h of x. And my formula says f prime equals g prime times h plus g times h prime. All right, well, if these are my g and h, then g prime is the derivative of x squared, which is 2x, and h prime is the derivative of x cubed plus 1, which is 3x squared. All right, so now let's just put all these pieces together. This is g prime, that's 2x, times h, which is x cubed plus 1, plus g is x squared, and h prime is 3x squared. All right, now I'm just going to do some algebra, clean this up. This is 2x to the fourth plus 2x plus 3x to the fourth, which is 5x to the fourth plus 2x. And that's it. There's my derivative. Now, you might have thought way back at the beginning, right? I can simplify this pretty easily. Right? F of x, if I distribute that x squared into the parentheses, this is x to the fifth plus x squared, and I can differentiate that easily enough. F prime of x is 5x to the fourth plus 2x. Yeah, look at that. I got the same answer both ways. Mathematician, we love to do this when we have a new concept. Right? We'll go back and do it with something that I can do both ways. Right, where I can use an old method and the new method and confirm that I get the same results. Right, that tells me two things. First, it tells me that my new method is working, and second, it tells me that I'm using it right. So why don't you take a look at this one, see what you can do. Right, then you can pause. Right, pause the presentation and start it up, and we'll go through it together. Okay, so let's see. This is going to be g. Just so we're clear, g of x is x to the 1/3, right? I'm going to immediately take that radical and make it a fractional exponent. That way I can use my power rule on it. Then this is going to be my h. So what do we have then? G prime is 1/3 x to the negative 2/3. And h prime is 2x plus 2. All right, then my product rule says f prime equals, let's see, it's g prime times h plus g times h prime. So g prime is 1/3 x to the negative 2/3, and h is x squared plus 2x plus 3, plus g, that's x to the 1/3 times h prime, that's 2x plus 2. And here I'm going to do kind of an unusual factoring step, but you need to get used to seeing this. Right? This is going to come up several times throughout this section. It's going to become really important in the next section when we start looking at applications. I'm going to factor out an x to the negative 2/3. All right, so let's see what that does. From this part, what's left is the 1/3 and the x squared plus 2x plus 3 plus, and what's left here? Here's where it gets interesting. What's left here is x times 2x plus 2, right? And to kind of see that, right, If you distributed this back into here, x to the negative 2/3 times x to the first is x to the 1/3. All right, now I'm going to go a little further, right? I'm actually going to factor out a 1/3. So let's make this x to the negative 2/3 times 1/3 times x squared plus 2x plus 3. What has to be left here? Well, it's the coefficient is currently a 1, right? 1/3 times what is 1? Well, that's got to be 3. So this is 3x times 2x plus 2. And let's see, now I'm going to move this x to the negative 2/3 down to the denominator. 1 over 3x to the 2/3 times x squared plus 2x plus 3 plus 6x squared plus, whoops, I was going to add there, plus 6x. And now we're done, right? Combine the like terms. 7x squared, that takes care of those. 2x and 6x plus 8x plus 3 over 3x to the 2/3. And that's it, right? There's the derivative of this thing. Okay, so how about this one? Now I'm mixing and matching, right? I've got some trigonometry going in here. But it's going to be the same thing, right? I'm going to let g of x be x and h of x be sine x. So g prime, that's nice, it's just 1. H prime is the derivative of the sine, that's cosine of x. So let's see, f prime is g h prime plus g prime h. That's x times h prime, that's cosine of x, plus g prime is 1 times h, which is the sine of x. So my derivative is x cosine of x plus sine x. And that's it, we're done. Right, now there's one thing you might have noticed. I'm not particularly careful about whether I do about the order that I do these things in, right? Do I do the first times the derivative of the second first, or do I do the derivative of the first times the second? All we're doing in this formula is multiplying and adding. This is the nice formula, right? Because multiplication and addition, they're both commutative. So the order for a lot of these pieces don't matter, right? I could have done g prime h plus gh prime, and it's the same thing, right? All I remember when I'm remembering the product rule is I have to take each function times the derivative of the other one and then add the two results together. And the order doesn't really make a difference. All right, so let's see. How about this thing? Okay, well, let's see. We don't have any way to handle what really is the composition of two functions, right? Instead of being the sine of x, I've got that sine of 2x. I don't have a way to do that yet. But look, what I can do is I can fall back on a trig identity and say this is 2 sine of x cosine of x, and take the derivative of this, because now I have a product, right? Sine of x is going to be my g, so g prime is cosine of x, and cosine of x is going to be my h, so h prime is minus sine of x. And now I can go to the formula. F prime of x equals, so you remember that 2. Remember, if there's a constant out in front, I don't have to worry about it. I can just let it ride out in front and do the derivative of the part that actually has the variables in it. So this is going to be, let me write it out. This is g times h prime plus g prime times h, which is 2, let's see, g is sine of x, h prime is minus sine of x, plus g prime, that's cosine of x, and h is also cosine of x. So what do I have now? 2 This is minus sine squared plus cosine squared. And I can flip these here. This is 2 cosine squared minus sine squared, but I know what that is. Cosine squared minus sine squared is cosine 2x. And there's my formula, right? And I want you to think about that for a minute. It's kind of what we expected a little bit, right? The derivative of the sine is the cosine. And you see the derivative of sine of 2x is cosine of 2x. And the only effect this 2 inside here had was I kind of had to end up with this 2 outside to adjust for that, right? We'll talk more about that a couple lectures down the road, right, when we talk about the chain rule. Okay, so now we have products down, right? We know how to take the derivative of the product of two functions. So kind of the obvious next question is, well, what do we do about quotients, right? How do you do the quotient of two functions? And that's what we're going to talk about in the next lecture. The formula is not quite as nice, just kind of giving you fair warning. But I mean, it's definitely usable. It's definitely going to give us a practical answer to that question.